Welcome to Penel Educate. In this video series, I'll be showing you formulas that you can use to treat problems relating to inclined planes, that is motion on an inclined planes, and we'll be solving several questions after that. Now, let's say you have a box seated on an inclined plane. Okay, the force perpendicular to this plane acting on the box is a normal force. We call it Fn. Okay, then we have another force which is acting down like this, okay, which we call the weight force. That's the weight force. Let me draw it properly. Okay, this particular one. Okay, that's the weight force, which we call mg. Now let's extend this particular line, down like this. If you extend it down like this, then we can make this a complete okay, we can make it a complete triangle. Now if we bring this one out, this triangle out, but before then, this particular angle here is also theta. What do I mean? Let's say that you have a 30-degree here. Okay, then definitely this place will be 90-degree, and what is going to remain here is 60 degree, and this particular one also is a right angle. Okay, so if you subtract 90 from 60, definitely this place is going to give you a 30. Okay, so that's what makes it theta. That what makes that angle the same as the angle of the inclined plane. So this particular one is also theta. Now let us take that triangle out. We have something like this. Okay, this is one. That is mg, and let's call this one a x. Let's call this one a y. Now let us find x. Don't forget this is theta. Let's find the x and y in terms of mg. Okay, so we'll use our normal formula. So Katua. Okay, so now this particular one, this one is opposite, and this is hypotenuse. So opposite hypotenuse, we use sine. That means sine theta is equal to x over mg. Okay, so that means we have our x to be mg sine theta. Okay, so this component here is mg sine theta. Then when we have this particular one is adjacent, this one is hypotenuse, so we use our cos theta will be adjacent, which is y, over hypotenuse, which is mg. Then we have our y component to be mg cos theta. Okay, so that means the component here is mg cos theta. Now, one thing that you need to know is that because this particular plane, this particular box is not going up or down the plane, okay, so that means this particular force, which is the Fn, that is normal force must be equals to mg cos theta. All right, so that is one formula that we must take note. Now we also have a force which is acting down like this, a force that accelerates the block down the plane. Then we'll call that one Fg. Now this Fg now is parallel to this particular force mg sin theta, so we can as well say that our Fg is equal to mg sin theta. That is the force that is acting towards the ground. That is the force that is pulling or that is accelerating the box towards the ground. Okay, that's what uh, that one is. Now let's look at block on frictionless inclined plane. Let us look at blocks on frictionless inclined plane. All right, so let's say we have a box seated on inclined plane, and then now we're looking at frictionless inclined plane. Don't forget these are y components, and this y component is the Fn, which is the normal force. Then we have our x component, which is the Fg, okay, which is accelerating the block down. This is an x component that blocks down. Now, the only force that is acting on this direction, moving the box down the plane, is only Fg. Now, the net force, which is F net force, is going to be Fg. Now, this Fg is the one pulling the block down, and because this is a frictionless inclined plane, the box will just be going down. Will just be going down. So the only force that is acting on it is the one that is pulling it down the plane. Then here, we know, don't forget our F is ma. Okay, so this is ma. That is mass acceleration, and from the first equation, we said our Fg is mg sine theta. That is the force acting on the plane, acting on the block towards the ground of the plane. So the acceleration down the inclined plane then will be, we don't need to consider the mass when we're looking at acceleration down the plane. So what it means is that acceleration down the inclined plane is independent of the mass. So we can cancel this mass out. Then we're going to have acceleration to be g sine theta. So please take note of this formula also. That is very, very important. Now let us look at when we are dealing with friction. Okay, so when we're dealing with friction, we know that, like I said before, for inclined plane, we have a force which is pulling the block down the plane. That is the one that we call Fg, and we have the friction force, which this particular one is a static friction. That's why we call it Fk. This friction force is opposing the motion. So friction is always opposing the motion. Okay, so now for a frictional force is the friction of a body in motion. All right, so this force is the kinetic friction. That is Fk, kinetic friction, which is the friction of a body in motion. While we have the Fs, which is static friction, that is the friction of a body at rest when it's not moving. Okay, so now, so we have Fk opposing this particular body that is going down the plane. Now, the sum of the force, that is the F net, is equal to Fg, which is this one moving here, plus this Fk, which is the negative kinetic friction opposing the motion. So when you do this, you're going to have Fg minus Fk. All right, so we then know that F net, which is the Ma, this one is the F net, this F net. Okay, this Ma, which is equal to Fg minus Fk, which is the kinetic force. Now, Fg, we already know in our calculation that Fg is mg sine theta. All right, but for kinetic force, which is Fk, we have mu k, which is the coefficient, multiplied by normal force, that is Fn. And don't forget that we already calculate our Fn in the last slide, that Fn is mg cos theta. So that means we have Fk to be mu k mg cos theta. So we'll put in this equation minus mu k mg cos theta. All right, so m a is this. Okay, so if you substitute m out, you can actually cancel that. M cancel this m cancel that. So I have a, which is equal to g sine theta minus mu k g cos theta. All right, so that's the formula we need to take notes. This particular one, we need to take notes while we're calculating the body moving down the plane in a plane with friction. All right, so let's look at a body that's a block sliding up the inclined plane. Let's look at a block sliding up an inclined plane. All right, so let us look at a block sliding up the inclined plane. So if we have a plane like this, okay, we have a body, that's the block sliding up the inclined plane. Let's say this going up here. Okay, so this is a positive x direction, it's going up. Then we have the normal Fg, that is the force causing the block to go down the plane. Then we have, because it's moving this way, because the body is moving this way, we have also the kinetic friction, that is the kinetic force, which is negative opposing it. So this other one also is a negative force opposing it. Okay, so now what is going to happen is that, don't forget, we still have our theta and all that angle of inclination. Then the sum of the force here, which is the F net, is going to be these two. These are the two forces, which is negative Fg and negative Fk opposing it. So the formula is not going to change really, but just um, the sign is one that will change. Don't forget, we see how this one as MA, and this one is minus mg sine theta, like we did previously. This one is going to be mu k, okay, which is mg cos theta. All right, so we'll still cancel our m out, which is the normal one that we utilize. So our acceleration will be minus g sine theta, okay, minus mu k g sine cos theta. All right, so the formula is not changing, only that the negative that's the negative sign that is here is the difference. So we have negative of this and negative of this, so we'll calculate our acceleration of an inclined plane going on. Okay, so this is another formula that we should take note. So once it's going up the plane, we have two forces opposing the motion. So Fk and this Fg, they are working together to slow down the block from moving up the plane. All right, let's quickly look at if the block is sliding up, but the incline is in a reverse direction. So if it's sliding up, let's do this. Okay, right. Okay, the block is sliding up. The block is sliding up like this, but the incline is coming this way, in the reverse direction. All right, so if that is the case, we're going to have the opposing force is going to be, that is the kinetic friction, going to be positive, and we're going to have the Fg to be positive. Okay, that is the force allowing to come down. So the Fg and the Fk will still bring it down. So Fk will still be the kinetic friction, like I said. So, but the only thing now is that the Fk and the Fg are positive. That is when the block is sliding up, but the incline is coming in the reverse direction. So we're going to have our net force. Our net force, which is the F net, is going to be equals to Fg plus Fk. All right. So by the time you work that one out, this particular one is Ma. Then it's got to Fg is mg sine theta, okay, plus Fk, which is mu k, that's the coefficient of friction, then mg cos theta. All right, so we're still going to have our m is cancelled out. We're going to have our a to be g sine theta plus mu k g cos theta. All right, so that is all about that. So let's quickly look at different examples. All right, so let's look at this example. A block slides down a 30-degree incline starting from rest. What is the acceleration of the block? B. What is the final speed of the block after it travels 300 meters down the incline? And we're asked to take G to be 10 meter per second squared. So if we quickly draw it, okay, we have the incline, a block like this. Yes, so you have 30-degree, okay, then it's starting from rest, slides down, okay, so we have our S component, which is the Fg, it's coming down. Don't forget, when you have it going down, you only have the block going towards, that's just the normal force acting on this. So we have the normal force acting up, then we have this. So from here to here, from here to here, we are given that from here to here is 300 meter. That is the down the incline in 300 meter. Then we have the normal force, which is acting up. So because it's sliding down the incline, the only force that is acting on it on the x direction is just the Fg. It's just the Fg, and our sum, which is the net force, is just equal to Fg. And don't forget that this one is Ma and our Fg is mg sine theta. Okay, then our acceleration will be a g sine theta. Like I said, a body sliding down the plane is independent of the mass. Okay, so we have our 10, which is g multiplied by sine 30. Our sine 30 is half, so 10 multiplied by half is 5 meter per second square. That is our acceleration. Now let's look at asked to find the let's look at the second question when we're asked to find the speed, that's the final speed after the block travels 300 meters down the plane. So I'm just quickly going to take this one out that we can use that place. All right, so now what is the speed? Then what we are giving is that we have our initial uh, velocity. So it's starting from rest. Sometimes initial velocity will be 0. Then we have to find the final, that the final speed, which we don't know. Don't forget that we already have our acceleration to be 5 meter per second square. Okay, so we then look at, we are given the distance of 300 meter. So if you look at the formula we're going to use, will be v square, okay, which is equal to u square plus 2 as, which is in our law of motion. And don't forget, this one is 0 square plus 2. This is multiplied by our 5, then multiplied by 300 meters. So if you do that, your v square will be 3000. Okay, so if you take the square root of both sides, so you're going to be v, the square root of 3000, and your answer will be 54.77 meter per seconds. So that's the velocity after it has traveled at down the plane at 300 meter. Okay, now we're given a 10 kg block begins to slide down a 30-degree inclined plane starting from rest. So the coefficient of kinetic friction is 0.20. Then we're asked to calculate the acceleration of the block and how far would the block travel after 20 seconds. Now, once you're given the coefficient of static friction, you should know that that body is acting under the influence of friction. So we're giving this to be 30 degree. Okay, so don't forget we have components of normal force acting up. Then said it's beginning to slide down. This is actually slide down. So if it's sliding down, we have this one as Fg, okay, which is positive. Okay, then we have the opposing force, which is a negative kinetic friction. So our F net, which is component, that's sum, will be this particular one, that is Fg, plus this particular one, which is a negative Fk, which is kinetic friction. Then we're going to have Fg minus Fk. Then don't forget this is Ma. Okay, so Ma will be, this particular one is mg sine theta minus Fk, which is mi k mg cos theta. Okay, so we can cancel out our m here. Just cancel that. We're going to have a with g sine theta minus mi k g cos theta. So we have a will be, you take our g to be 9.8, we're going to have 9.8 multiplied by sine 30 minus mu k, we're given 0.2 multiplied by 9.8, then cos 30. All right, so do your arithmetic very well. Go to have this one as 4.9 minus 1.697. Then our answer will be 3.2 meter per second square. Right, so that's our acceleration. Okay, so we're asked to find how far will the block traveled after 20 seconds. Okay, after 20 seconds, how far will the block travel? So let's do that calculations. We know that we have our initial, because the question is about the block sliding down. Okay, so that means the initial velocity will be 0. Okay, the time that is going to take 20 seconds, we're giving time to be 20 seconds. So we're going to find how far to go, which is the final velocity after 20 seconds. Okay, so we can use, we have this is u, which is 0. Then we have time, which 20 seconds. How far is about the distance it will be after 20 seconds. So we can use our s, which is s is ut. Okay, that is plus half at squared. Okay, so and we have u to be 0. This 0 multiplied by 20 plus half. Okay, then multiply by 9.8, which is our acceleration due to gravity, then multiply by 20 square. So if you do that, you're going to have 640 meters. So after 20 seconds, the block would have traveled 640 uh, meter. Travel 640 meter. All right. So let's look at another example. Okay, so assuming that we have this diagram, don't forget sliding, you have the force acting on it downward at 12G and the force opposing it to be Fk. Don't forget we also have the normal force acting on the block. Now, with this block slide down, or will it remain at rest? Okay, with this block slide down, will it remain? Don't forget we are given this mu k, which is the coefficient of static of kinetic friction to be 0.10 and the coefficient of static friction to be 0.0. So now, if the body is moving, is a kinetic friction, and if it's not moving, is a static friction. That is Fs. Now let us look at. Then we have this particular one, which has our Fn, which is normal force. We have it as mg cos theta. So, and we're giving our mass to be 10. Then let's take this one to be also 10. That is a g. Let's take g to be 10 meter per second square. So we have g, which is 10, and then multiply by cos 30. If you do that, we're going to have 100 multiplied by cos 30. Cos 30 is 0.8660 multiplied by 100 will give you 86.6 Newton. So that's our normal force that is acting on the body. So we want to confirm if this body will slide down or not. Now let us look at the Fk, which is the kinetic friction, which is mu k multiplied by Fn. All right, so we have mu k is given as 0.10 multiplied by 86.6 Newton. So we do that, it's going to give us 8.66 Newton. Now we need to find our Fs. We need to find our Fs, and our Fs is less than or equal to mu s Fn. So let us find our Fs. So less than or equal to, going to have mu s is 0.30 multiplied by our Fn, which we've gotten before. It is 6.6 Newton. Okay, so when we do that, we're going to have this is to be 25.98 Newton. That is our Fs, that is static friction. So now, if Fg, exceed, if Fg exceed, that is greater than Fs, that means if the force pulling it down is greater than the static friction, the body is going to slide down. That means the block is going to slide down. And if not, if it's not greater than, or if it doesn't exceed, then it's going to remain at rest. So if we calculate the Fg now, let's calculate our Fg. Clean this place up quickly. So the things that we have, one of the things that we have is that we have our Fk to be 8.66 Newton. We have our Fs to be 25.98 Newton. Okay, that's one of the things that we've calculated. Now, let us find our Fg. Our Fg is mg sine theta. Okay, then our mass is 10. Okay, and we have our g to be given as 10, then multiply by sine 30. Okay, so this is 50 Newton. We've done that. Now, don't forget that we have our Fs, which is the static friction to be 25. So this is 50. Fg is 50. So this one exceed this. Okay, because this one exceeds this. So what it means is that the body will slide down. The body will slide down because the Fg exceed the static friction. Now the net force about the time that is so the net force about the time is going to be sliding down. Don't forget this one is going down and this one is going to be opposing it. So we're going to have our Fg minus Fk, okay, which we've done before. Ma will be mg sine theta, then minus mu k mg cos theta, right? Cancel our m. Once cancel our m, we're going to have our a to be g sine theta minus mu k g cos theta. So if you put all our question there, this is 10, okay, sine 30 minus mu k, which is 0.10 times 10 times cos 30. So if you do this arithmetic, our acceleration is going to be 4.134 meter per second. Okay, that's our acceleration. Now, one thing that you need to take note is that your acceleration down the incline should not exceed the acceleration due to gravity. So if you are given the acceleration due to gravity to be 10 meter per second, 10 meter per second square, then your acceleration should not exceed 10 meter per second square. So if you have answer that is greater than 10 meter per second square, then you should check that means that answer is not correct. Okay, so that means the answer is not correct. So let us look at what point. Let's look at what point will the block slide. If we have things like this, at what point will the block slide? Don't forget I said once the Fg exceed the Fs, which is the static friction, the block will slide. But at what point, at what critical point, would they slide? So at the critical point when you begin to experience the sliding is when Fg is equal to Fs. Okay, and don't forget our Fg is mg sine theta, when we have our Fs to be mu s, okay, which is then Fn, but our Fn is mg cos theta. So we have our mg sine theta to be mu s mg cos theta. All right, so we can cancel out our mg, it's cancelled out like this. So we have our sine theta, which is equal to mu s cos theta. So if I divide both sides by cos theta, I'm going to have sine theta over cos theta, and I'm going to have this one divided by cos theta is going to be mu s. Okay, and this particular one, which is the mu s, this one is tan theta. So our mu s is equal to tan theta. Okay, our mu s is equal to tan theta. So if you want to find this angle, which is the theta will be, arctan mu s. So to find the critical angle, it will start to slide against the static friction. If we are given that, say our static coefficient of static friction is given, if our mu s is given to be 0.25, then to find the angle that body will start to slide, we are going to have theta is equal to arctan 0.25, which is about 14 degree. Okay, so with this, we've come to the end of our topic on inclined planes. We want you to subscribe to our YouTube channel, share with your loved ones, share with your friends. I want to hear feedback from you if this particular video has been very, very informative for you. So please feel free to send us feedback and we'll be able to respond very soon. All right, so join me next week for another uh, video series on physics. Bye.